Okay, welcome back to math class. Yesterday we talked about basically the definition of the central angle and arcs in a circle. Today we're going to talk a little bit more about what we can do with that information once we have it. So we talked yesterday about when I have my circle and I have a central angle, we have a minor arc and a major arc, a small one and a big one. That's what we learned yesterday. Something else to note is if we have congruent arcs, in other words, arcs that have I know it's not exactly perfect, but if I told you that this angle and this angle are congruent, then I'd also be telling you that this arc and this arc were congruent. That makes sense. Congruent arcs have to have the same angle measurement, they have the same length, and the same central angle measurement. That's congruent arcs. What else we know, or a different kind of arc we're going to be talking about, is what happens if we have adjacent arcs. So let me label this circle. Let's say this is circle A, and I have points B, C, D, E. Now what I've already given you the information that BC and ED are congruent. I know it doesn't look exactly like that here in this drawing because my center is actually a little off center. But if I told you this was true, I would know that those are congruent arcs. They have the same angle, the same measurements. What else we can tell is that BAC, this angle, is adjacent to or next to, remember that from our talking about angles, CAD. So it's BAC is adjacent to angle CAD. Remember when we have two adjacent angles, what we know is that they share a side. BAC, CAD. They're these segments that are right next to each other. What we know about adjacent arcs is the same as what we know about adjacent angles. If I have this plus this angle, it's going to give me this whole angle. So the measurement of angle BAC plus the measurement of angle CAD will give us the measure of angle BAD. That's kind of funny. So if I told you that this angle was 85 and this angle was 95, then you could figure out that this whole thing is 180 degrees just by adding those together. The next thing we're going to do, let me erase this. So that's with congruent and adjacent arcs. The next thing we're going to talk about is what to do if I gave you the length of the arc and you didn't know necessarily anything about the angles. So what we know about the arc length in a circle is that the arc length to circumference ratio, this ratio is proportional to the central angle measurement over 360. So if I break that down into what it means in an actual circle, let me make myself an arc. This arc, whatever its length is going to, its length divided by the total length, the total circumference, the total distance around the circle is going to be proportional to the measure of this angle compared to the measure of the total angles of the circle, the total angle measurement of the circle, which is 360 degrees, and we already know that. We also already have a formula for circumference, so we can rewrite this as the length, the arc length, divided by our circumference, which equals, here you don't have to put C equals, but our circumference equals 2 times pi times r, or pi times the diameter, and that's proportional to the measure of angle x over 360. With this proportion, all you need is the radius of the circle and the length of an arc, and you can find the angle, or if they gave you the central angle and the length, you could figure out the radius, or if they gave you the radius and an angle, you could figure out the length. So that's what this is helping us with. So let's practice one. I know that can get confusing. If I gave you that this was 60 degrees and that the radius here is 6, and I said, find for me the arc length. Well, I won't use an X, I'll use an O. Find for me the arc length of this portion of the circle. All I have to do is plug these numbers into these formulas. So I'm going to take my L divided by 2 times pi times 6 equals 60 over 360. Now all that's left is to do my algebra to solve for L. So what I can do to get L by itself is do 60 divided by 360 times 2 times pi times 6. You can put all of that in your calculator or solve it step by step. Either way, you're going to end up with L. Again, we're being approximate because we're using pi, which has an infinite number of decimals. So we're going to round to the nearest hundredth. We're going to get our L is approximately 6.28.